All right, hey everyone, good afternoon. Hope your day is going well so far. So today we're actually going to be continuing what we did yesterday with matrices, right? Yesterday we converted a system of equations to a matrix, and then we solved using the procedure, right, to get in like staircase pattern, and then we also want ones as the leading entries. That procedure actually has a name to it. It's Gaussian elimination, which I alluded to yesterday, but today we'll actually see the definition formally in, on the slide. But yeah, for now, just please copy down the aim, which is practice using Gaussian elimination to solve systems, and begin to do now as well. So for that, just recall the three elementary row operations of a matrix. So that if you remember from yesterday, right, there were three things we could do to, solve a system of equations and still maintain the equality of the matrix, right? So even if we do these three row operations, we still end up with the same solution. Okay, I'll give you another 30 seconds to do that, and then we will discuss. Okay, so let me pause you here. All right, I'm gonna scroll up for the solution. Okay, so again, the question asks us to just identify the three elementary row operations of a matrix, and here they are. So the first one was add a multiple of one row to another. Two is interchange the rows. Nothing really profound about that. That's like, if you think about a matrix, as a system of equations, right, that's just like rewriting where the equations go. Okay, and then third, we can multiply a row by a non-zero constant. So that's also nothing new. That could technically be included under one, right? Because in number one, we're multiplying one row by a non-zero constant. But yeah, those are the three operations that you'll see when solving a matrix. All right, I'll give you some more time to copy that, and then we will move on to the rest of the lesson. Okay, does anyone still need to copy the do now solution? Okay, if not, then I'll move on. So today is just pretty much a review of yesterday, but we're going to formalize some of the definitions and also the procedure that we saw yesterday. So that procedure, again, is called Gaussian elimination, again from the aim. And then we're also going to define an augmented matrix, which we saw yesterday, but yeah, we'll have the definition here. And then that'll be followed up with an example. Okay, so with that being said, let me scroll down to the notes. All right, so again, this is Gaussian elimination, and can I get a volunteer to read this slide, please?
I can read.
All right, go to
Gaussian
yeah, go
Gaussian
ahead.
elimin Gaussian elimination. The procedure we saw in the previous lesson is called Gaussian elimination, named after C.F. Gauss. To summarize, 1. Write the augmented matrix of the system. 2. Use elementary row operations to change the matrix to row echelon form. 3. Write the new system of equation that corresponds to the row echelon form of the matrix and solve.
All right, thank you for that. So yeah, nothing new here. This is just summarizing and naming the procedure from yesterday. Again, it's called Gaussian elimination, named after the German mathematician Karl Gauss, one of my contemporaries back in the day. And I think I said this yesterday, but I did give him a shout out in my rap battle last year. Does anyone remember the line that mentions Gauss? All right, if not, then you can watch the video again. But yeah, I did mention him in one of those lines. All right, but yeah, I'll give you some more time to copy this, and then we'll go on to the next definition. Okay. Is anyone still copying this slide here? Type in the chat or speak up. Okay, not then I'll move on. All right, and I think I saw Sammy raise his hand earlier. Could you read this definition here?
An augmented matrix is a matrix whose entries are the coefficients and the constants of a system. In other words, it includes the numbers from both sides of each equation.
Okay, thank you for that. So yeah, we saw this yesterday. We included both sides of the equation in the matrix, and yeah, they're just naming what that's called. It's an augmented matrix. The reason I'm including this here is because you'll see this, vocab word again if you take linear algebra, and I don't know if you'll see it on the homework directions, but if we had the textbook, in that we normally use for this class, then they use this vocab word, so I do include it here. Okay, does anyone still need this? Okay, if not, then I'll move on. So last slide is just an example of Gaussian elimination problem. Okay, so we're going to solve the following system using an augmented matrix and Gaussian elimination. Okay, so let me scroll up for that, and you can also see the problem there. All right. All right, here it is. So augmented matrix, again, that just means we're including both sides of the equation, which we did already yesterday. And then we're going to use Gaussian elimination, which again, that's the name for the procedure that we saw yesterday, right? We want the row echelon form, right? The staircase pattern and ones as the leading entry. And any row with zeros, we want that to be at the bottom. But That doesn't come up that often, at least in the problems that we're going to solve in this class. All right, anyways, here's the system of equations. We have x minus 2y plus 3z is 1, which I write as 1, negative 2, 3, and 1 in the first row of the matrix. Then we have x plus 2y minus z is 13, which is 1, 2, negative 1, 13 for the second row. Then we have 3, 2, negative 5, 3 in the third row. Okay, so this is the initial, matrix. I'm first going to do R2 minus R1. Okay, so I'm going to take R2 and then subtract R1 from it. So 1 minus 1 is 0, which I have there. Okay, and then 2 minus negative 2 is 4, which I have here. Negative 1 minus 3 is negative 4, which I have there. And then 13 minus 1 is 12, which is the last entry in that row. Okay, next I'm going to do also R3 minus 3R1. And for that, I actually write out negative 3R1. If you could do the mental math, feel free to do so. But personally, I, always mess up when I do that. So I like to actually write the row with the numbers themselves, just to help me keep track. Okay, so R3 minus 3R1. Now, negative 3R1, you just take R1 and multiply by negative 3, right? So negative 3, 6, negative 9, and negative 3. Okay, that's what we have here. So we're going to do R3 minus 3R1. You could also see that as R3 plus negative 3R1 technically. Right, so we can see it like that. That actually might be more helpful in this case. Okay, so R3 plus negative 3R1. So you see R3 here, 3, 2, negative 5, 3. We're going to add this row to it, right, negative 3R1. Okay, so 3 plus negative 3 is 0, which we have there. Then 2 plus 6 is 8. Then negative 5 plus negative 9 is negative 14. And then 3 plus negative 3 is 0. Okay. All right, that's the first two operations. And then that's going to be followed by R3 minus 2R2. And again, the goal here is to get the staircase pattern, right? So we want zeros below, quote unquote, like the staircase. So instead of 1, 3, and 2, which we have here, right, we want those to be zeros to get the staircase pattern. Right? And the staircase pattern, of course, like algebraically speaking, that would give us equations that we can solve for, right? That will give us a system of equations in which the last row represents like z equals a number, and then from there we can solve for y and then x. Okay, that's why we want the staircase pattern. Okay, all right, but yeah, so now we have zeros here and here, right? So we want a 0 instead of the 8. Okay, so for that I'm going to do R3 minus 2R2, right? Because minus 2R2 is going to be negative 8 in this entry, right, in that column. And if we add that, we're going to get 0. Okay, so negative 2R2 is 0, negative 8, 8, negative 24. So all I did there was multiply the second row by negative 2. Okay, and then, so I'm going to modify R3. So I'm going to do R3 minus 2R2, right? Again, you can see that as R3 plus negative 2R2. Write that there. Okay, so you can see like that as well. Anyways, after you do that, so R3 is referring to this old R3, right, row 3. So it's 0 plus 0 is 0. Then we have 8 plus negative 8 is 0. Then negative 14 plus 8 is negative 6. Then 0 plus negative 24, that's just negative 24. Okay, so that's row 3. All right, so we're almost done. All we have to do now is, so we, instead of 4 and negative 6 here, we want 1s, right? We want each leading entry to be 1. Okay, so I'm going to do 1/4 times R2, and then negative 1/6 times R3. And if we do that, 1/4 R2 is going to be 1, negative 1, 3, right? Just 1/4 times each of these. and then negative 1, 6, R3 is going to be 1, comma 4, right, or 1, 4. Okay. All right, and that completes our process of Gaussian elimination. All right, we have the staircase pattern here, and the leading entry, right, the first number in each row is 1. Okay. All right, at this point, we convert it back to a system of equations. So we have x minus 2y plus 3z is 1, y minus z is 3, and z equals 4. Okay. All right, and that'll be our answer. I also write it like this. I make a note of that here. So x equals 3, y equals 7, z equals 4. And I know, we don't have the textbook, but if we did have the textbook also writes it like this. So this is actually a three-dimensional vector. But yeah, this is how they actually write it in the answer key. So yeah, 3, comma 7, comma 4. All right, give you some time to copy that, and then we'll move on to the next problem. Okay, does anyone still need this solution here? All right, if not, then I'll move on. Okay, with the 5 minutes we have left, I actually will show you the homework for not the one due tonight, but this is the one that is going to be due tomorrow. Okay, so for the homework that's corresponding to this. Okay, so this is homework number 81. Again, this is the one due tomorrow, not tonight, and this is the homework corresponding to this lesson. Okay, so let's go through some of the problems. Number 15 was x minus 2y plus z equals 1, y plus 2z equals 5, x plus y plus 3z equals 8. So first thing you do is you write the augmented matrix. You have 1, negative 2, 1, 1, 0, 1, 2, 5, 1, 1, 3, 8. Okay. So first thing I'm going to do, we already have a 0 there in the second row, but I want a 0 also in the third row. So I'm going to do R3 minus R1. So 1 minus 1 is 0, 1 minus negative 2 is 3, 3 minus 1 is 2, 8 minus 1 is 7. Okay. And by the way, feel free to, this gives you a head start on the homework. So I would, follow along on paper, so you at least have, the problems written down, and you can submit that, right? All right, next we want so we have zeros here now under the 1 in the first column. We want a 0 here in place of the 3. Okay, so I'm going to do R3 minus 3 times R2. Now, minus 3 times R2, that's going to be written down here, right? So that's going to be 0, negative 3, negative 6, negative 15. Okay, and then I'm going to add that to row 3. So 0 plus 0 is 0, 3 minus 3 is 0, 2 minus 6 is negative 4, 7 minus 15, that's negative 8. Okay. All right, last step is to do negative 1/4 R3, right, to get a 1 there in place of the negative 4, and that will make R3, row 3, into 1, comma 2. Okay. Well, actually, no, I shouldn't say comma. Yeah, just 1, 2. Commas would be reserved for the final answer. Just clarifying. Anyways, we're going to write the matrix now as a system of equations, so that would be x minus 2y plus z equals 1. We also have y plus 2z equals 5, and then z equals 2. Okay, so z equals 2 here, that's already solved for. Next, I'm going to solve for y, so y plus 2z equals 5. That's y plus 2 times 2 equals 5, which would make y equal 1 after subtracting 4 from both sides. And then lastly, we're going to solve for x. So x minus 2y plus z equals 1. So that'll be x minus 2 times 1 plus 2, right? Z is 2 equals 1. Minus 2 plus 2, that's 0. So that will leave us with x equals 1. And so our final answer is going to be 1, comma 1, comma 2. Ryan, thank you for finding that verse, but are you copying this down?
Yeah, I took a picture of it.
Okay, all right. Appreciate it though. I wanted you to search it up earlier, not like now when we're doing the homework. All right, but yeah, that was the shout out that I gave to Gauss. All right, really quickly for 17, we have x plus y plus z equals 2, 2x minus 3y plus 2z equals 4, 4x plus y minus 3z is 1. You write the coefficients, right? 1, 1, 1, 2, 2, negative 3, 2, 4, 4, 1, negative 3, 1. And so again, we want zeros here and below the 1. So I'm going to do R2 minus 2R1 and R3 minus 4R1, right? Negative 2R1 is, so you multiply the first row by negative 2, you get that, negative 2, negative 2, negative 2, negative 4. Negative 4R1 is negative 4, negative 4, negative 4, negative 8. And then you're going to add that to their respective rows, right? R2 minus 2R1, that'll be 2 minus 2 is 0, negative 3 minus 2 is negative 5, 2 minus 2 is 0, 4 minus 4 is 0. And then R3 minus 4R1, that's 4 minus 4 is 0, 1 minus 4 is negative 3, negative 3 minus 4 is negative 7, 1 minus 8 is negative 7. All right, and then next I'm going to just multiply both the second row and the third row by negative 1 to get positive numbers. And I'm actually in the next step going to write this as a system of equations now. And I know this is not in Gaussian elimination, right, because there's no staircase pattern and the leading entries are not 1. But, you know, since we have 0, 5, 0, 0 here, this represents the equation 5y equals 0. And from there we can actually solve the system. And yeah, you can do that. I'm okay with you doing that. So if you start Gaussian elimination and then you end up with a matrix that you can solve already, you can just feel free to convert that to a system of equations again and then solve for the variables. Okay, so x plus y plus z equals 2, that's 1, 1, 1, 2, right? 5y equals 0 for the second row, 3y plus 7z equals 7 for the third row. So from there, y equals 0, and then I'm going to solve for z using the third equation. 3y plus 7z is 7, so that would be 0 plus 7, z is 7, which would give us z equals 1. And then for the first equation, x plus y plus z equals 2. So x plus y, which is 0, and then z is 1, that equals 2, so that gives us x equals 1, which gives us the final answer of 1, 0, 1. Okay. All right, but I'll leave it there. For closing announcements, the only thing is there's SGI today, per usual, 2:47. Drop by if you have questions. But yeah, other than that, if you have no further questions and you're done copying this, you're free to go, and I'll see you all tomorrow. All right, take care.
Have a good day.
All right, thank you too.
Thank you. Have a good day.
You too, thank you.
Have a good day.
Thanks, you too.